All right, we'll go ahead and get started. Hi, everybody. Thank you for joining us this morning. I am Maisie Auld from Edge Environment. Edge Environment is a sustainability consultancy, and we've been working with NIFPI and Timberlink on this project, which is called essentially how to help wood product manufacturers take action on climate change. At Edge Environment, I lead our carbon and climate resilience work, and I'm joined here with my colleague Joana Almeida, who works largely on life cycle analysis. You want to introduce yourself?
Yeah, hi everyone, good morning. I am a senior sustainability consultant here at Edge, and I specialize in life cycle assessment, and because it's so closely linked to greenhouse gas accounting and climate change action, I work very closely with Maisie, so it's kind of right hand on this project.
So as I said, we received this funding from the National Institute for Forest Products Innovation, as well as Timberlink, to develop carbon reduction target methodology and associated tool for the Australian wood product manufacturing industry. So this set of resources focuses on that wood product manufacturing sector, but there still are benefits that can be taken from other parts of that supply chain as well. So all of the resources that have been developed through this project will be publicly available on the NIFPI website. They're not there yet, so I unfortunately don't have an exact web address to give you, but if you reach out to myself, Edge Environment, or the NIFPI reps, you can find that information once it's been uploaded, and it should be uploaded within the next couple of weeks. So this is the second of two webinars. We held a webinar this time last week, and that was really exploring the role of wood and timber plays in a low carbon future. And we did a high level overview of sort of the industry drivers and project outcomes. So that also will be available on the NIFPI website. So if you missed it, do feel free to go back and watch that one, as it'll sort of give you a bit more context as to what we're talking about today. So this is the second of those two webinars, and the purpose of this one is to go over primarily this tool that we have developed in Excel to allow companies to essentially easily undertake a carbon footprint assessment and understand the associated science-based emission reduction targets. So today I'm giving you a bit of background on the project, which essentially is what I've just done. I will give an overview of what science-based targets are, because that's a lot of very involved in this project and the outputs. We won't go into too much detail there, and that's largely because that's part of what we answered in the previous webinar. But as I said before, the resources that will be available online will go over that. And you can also use the Science-Based Targets website to understand a bit more about what that is if you have any questions there as well. That's sciencebastargets.org. Then we'll jump into the tool and we'll basically show you how that works, and we can then take some questions at the end of the session. So the premise of this piece of work is that we're aiming to assist companies within the wood product manufacturing sector or the timber industry as a whole along their climate action journey. So from a very high level, when we look at what that journey is, the first step is to understand your carbon footprint. So what are the emissions of your company, both your direct emissions as well as your indirect emissions. So by indirect emissions, we mean your scope 3 emissions that are up and down your supply chain. And as we dig into the tool, we'll talk a bit more in detail about what those actual emission categories are and the data required to understand those. So the second step is to then set a science-based target. So we're using that term science-based targets a lot here, and there's sort of the capitalized SBT and then the lowercase. Specifically when we talk about the capitalized SBT, that is an initiative, which I will discuss in more detail in a few moments. But mainly what we mean by science-based targets is targets that are set to reduce carbon emissions within your organization, and they are based on the latest climate science. So there's that science backing as to basically to inform the amount of reduction that you are targeting. The last steps are to engage your stakeholders and to drive change. So specifically on engaging stakeholders, that's stakeholders across your company. So not only your employees, but your board, and then as well your consumers, and up and down your supply chain as well. So going into that first step a bit more in detail, you can start by using the carbon calculator. So this is what we have developed, but you could also use other resources to understand your carbon footprint. But essentially the first step there is to set a boundary as to what you are going to cover in your carbon footprint. So what we've done for the carbon calculator that we have developed is alignment to the greenhouse gas protocol. So that is international best practice, and that really is that recommendation as to what you should be defining as what's inside the scope of your footprint and what's outside the scope of your footprint. You then want to collect data, and we'll go through the very detailed data requirements when we jump into the tool in a moment. And then the third step here is to analyze the data or the results. So not only will you be able to see hotspots within a single year of your footprint, but it's also allowing you to track your emissions over time to understand how they might be either increasing, or if you've been implementing mitigation actions, how those are tracking and decreasing over time. So it's a really good way to understand a bit more about your business and also to utilize the outputs of this calculator in things like annual reporting. So what are science-based targets? As I said, the Science-Based Targets Initiative is made up of these partner organizations here. So CDP, UN Global Compact, World Resources Institute, and WWF all fund the Science-Based Targets Initiative. So over 1,000 companies have joined globally, and that's across a range of sectors. And basically what the initiative is it's a body that has created a methodology for setting emission reduction targets that align to the climate science. And they also serve as a validation body. So essentially, if you're a company, you use their methodology to set a science-based target, submit it to them, and they will then validate that the targets that you have set do align to that science-based target methodology. So when we say a science-based methodology, what we mean is alignment to a 1.5 degree scenario or a well below 2 degree scenario. The 1.5 degree scenario is considered best practice, and basically that's coming out of the Intergovernmental Panel on Climate Change in saying that as a society, globally, we need to limit warming to 1.5 degrees. So what that means for a pathway and a company is that you are then aiming to achieve net zero emissions by 2050, and you are on that decarbonization curve. And that curve is actually steeper between now and 2030. So essentially we need to see more decarbonization within the economy over the next 10 years. So we've talked about those kind of high-level steps of understanding your carbon footprint. So the next step is developing those carbon reduction targets. So the first step is committing to set a target, which that's a voluntary step. You can choose to do that through the Science-Based Targets Initiative. You certainly don't have to, but it's an option that's there. And then it's to scope out that target. So do you want to set to that 1.5 degree scenario, which is international best practice and recommended by the science community, or you can choose a well below 2 degree target, which essentially is a stepping stone along the way to, in time, setting that 1.5 degree target. And you can also determine the year that you want your target to be set, and the level of ambition for your scope 3 emissions. And we'll talk more about all of this when we jump into the tool as well. But basically, you then want to calculate your target and lastly, communicate that target to the public. So you want to have transparency in terms of what type of commitments you are making. So specifically looking at the tool we developed, it is Excel-based. And as we've said, it allows you to estimate your carbon emissions, as well as helps you to understand what the associated science-based target would be. And we've developed this tool to be aligned to international best practice. So that's utilizing resources and aligning to things such as the greenhouse gas protocol, the science-based targets methodology, using emission factors and alignment to national greenhouse gas accounts and Australian timber EPDs. So to do this tool, we've firstly used Timberlink as a case study. So we worked with Timberlink to understand their carbon emissions and set their science-based targets, which they have now had approved, which is really great. They are the first in the industry in the region to have a science-based target. So it's great to see that. And basically, we used their data to help develop this tool. Once we had the tool developed, we then undertook user testing stage. So that went out to a number of industry members to test the tool, provide feedback, which we then incorporated into this final version that you'll see here today. This resource is free to use and it's going to be available on the NIFPI website. So I'm just going to jump into the tool now. Everybody should be able to see an Excel spreadsheet. So this is the initial introduction tab on the tool. Gives you a bit of information that we've already discussed in this presentation, but you can come back to this tab for this more information here. This is the questions tab, and this is really a very important tab within the tool. So basically in this questions tab, this is where you're going to be inputting all of your information and your data upon which the carbon footprint results and the science-based targets results are based. So in the very top section, we have initial questions. So right now we basically input the tool with some dummy data. Don't read too much into everything. I think every value has 100 in it. So we're not going to be seeing a perfect footprint here representative of the timber industry, but it is just to show you sort of how this tool works and the type of results you can get from it. So in this entire sheet, there are cells that are highlighted in yellow, and it's those yellow cells where you basically want to input information. So we have your company name, and then you can choose a base year for assessment. Now, the base year for assessment, that is essentially the year upon which your target is based. So if you're using it for target purposes, then you want to, keep that in mind. If you're just using it to understand your carbon footprint, then you could really choose any year for which you want to collect that data. But basically, when you're thinking about what year should be a base year, you want to use the most recent year that represents business as usual and for which you have the best available data. So really you want that data so that you can have a detailed and accurate carbon footprint results, but then you also want it to be representative of a typical business year so that you're not seeing really skewed results, and it then allows for tracking over time that is representative of what your business looks like. So then you want to choose a target year. So your target year should be between 5 and 15 years from now. And when you have a science-based target or any type of carbon reduction target, if we have a base year of 2018 and a target year of 2030, what that means for that target is you would say something like, I Love Timber commits to reduce emissions 50% by 2030 from a 2018 base year. And we'll look into what that means a bit when we get onto that science-based target results tab, but that's just to give you an idea of what these years are used for. That's the premise for it. So the next step here is to choose a level of target ambition for your scope 1 and 2 emissions. Again, if you're using this tool initially just for carbon footprint results, it doesn't really matter what data you're putting in for those target information. It doesn't impact the footprint results, but this is here so that if you enter this here, it shows up in your science-based targets results. So as I said before, you can choose a well below 2 degree pathway or 1.5 degree pathway. That 1.5 degree pathway is alignment to the latest climate science. However, officially through the Science-Based Targets Initiative, you can still set targets to that well below 2 degree pathway. And that's essentially the initiative recognizing that the 1.5 degree recommendation is quite recent. And so some companies will need a bit of time and sort of support to get there, and that well below 2 degree pathway is a way to get there. It is recognized that if you set a science-based targets officially through the initiative to a well below 2 degree pathway, you would likely be needing to update that target within the nearish future, so maybe 5 years or so. I can't really put an exact timeline on it, but you will need to update it to that 1.5 degree pathway at some point in time. So you can also choose a level of target ambition for your scope 3 emissions. So best practice is again aligning to that 1.5 degree pathway, but you certainly don't have to. So the Science-Based Target Initiative recognizes that scope 3 emissions you have less control over, and therefore allows you to have a lower level of ambition when setting a target around these emissions. So there's a couple of different approaches here. So there is a absolute reduction approach, a physical intensity approach, and then that sort of science-based backing, which is the well below 2 degree pathway and the 1.5 degree pathway. I won't go into too much detail as what each of those approaches means, as those are available here and in some of our further resources. But basically, when we're looking at these, the absolute approach is a % reduction over time. Physical intensity approach means that on a physical intensity basis, so in the context of the timber industry, we're talking about cubic meters of throughput. You can achieve this minimum emissions reduction as per this as per the science-based targets guidance. And then these other ones are simply alignment to that either well below or 1.5 degree pathway. We recommend choosing these different options because they do translate into different levels of ambition, just to sort of play around with and see what you're comfortable with committing to. So then we have a growth rate. So in setting targets, it is important to understand essentially not only where you are in that base year, so in this context, it's 2018, but also if you were to go about your business as usual practices, where you would be in terms of emissions in, say, 2030, which is your target year. So what we want to understand is we can communicate that target in terms of where you are right now, so in terms of 2018 or reduction against that. But what it means for your business is not just the reduction against 2018, but how you're going to maintain that growth over time for your business, assuming it's growing, and what that reduction is in your target year, because it's likely to be much greater than any reduction in 2018. And we have some graphs to sort of demonstrate that idea as well. So we have, the next one is basically your throughput, so meters cubed. This is to understand that physical intensity side of things. So you can set a target which is both just absolute and or intensity based. So if it's intensity based, that's going to be communicated on a per cubic meter throughput basis. Versus an absolute target, which is communicated on just an absolute reduction. So something like 30% reduction across all emissions versus 50% reduction per cubic meter throughput. To take it sort of out of an industry perspective, but one that's quite easy to understand. For example, Coca-Cola has a science-based target, and I can't remember exactly what the percentage is, but it's something like committing to reduce the drink in hand by 50%. So that's a physical intensity target and how you would be starting to communicate that. Up here in this section, we also ask for FTEs per location. And this is basically to estimate employee commuting. This obviously is not incredibly precise, right? It's based on some high level assumptions, and my colleague Joana will discuss what the reasons behind this data request, but essentially the most detailed and precise way of doing this would be undertaking an employee survey to understand their commuting practices. However, with this tool, we recognize that that is a more intensive data collection exercise, and our goal here is to provide a carbon footprint that is accurate enough from which you can track your emissions and you can set meaningful targets against. But it recognizes that data collection is difficult within many companies, and so we're basically trying to find that balance between detail and accuracy. And this is an acceptable way of measuring employee commuting. So I'm just going to hand over to Joana to talk about some of the data requirements in the tool.
Yeah, so like Maisie mentioned, we based the tool development on Timberlink as a case study. So essentially what that allowed us to do was to understand that boundary question. So it's really a step that a user of the tool won't probably have to do because Timberlink provided us what's the scope of a footprint on a typical company in the sector. It also allowed us to understand the type of data that a company has at hand and how the supply chain works essentially. So we could understand how to actually, create an abstract model of the footprint and understand what should typical emission sources be, what kind of background information like emission factors be, and all of that. So what you see here in this table is the breakdown of a footprint into categories. So the Greenhouse Gas Protocol splits organizational carbon footprints into these little categories. So you've heard Maisie talk about scope 1, 2, and 3 emissions. Scope 1 emissions are the direct emissions from the company's activities. So if there's any fuel, if there are fuels being burned in engines and boilers and vehicles, if there's refrigerants leaking to the atmosphere, those are scope 1 emissions. Scope 2 emissions are associated with the generation of electricity that is purchased by the company. And then scope 3 emissions is basically everything else. It's all the emissions up and downstream in the supply chain, things like the embodied carbon of the products that the company purchases. So in this case, a big chunk of that is going to be, of the purchased products, going to be the logs that go into processing, and then everything else like equipment and treatment chemicals, things like that. There's going to be capital goods, so in that case, actually the equipment would fall into there. If there's any kind of assets being built, like buildings, it would also go into there. Fuel, scope 3 of fuel and energy related emissions is actually upstream of those scope 1 and 2 emissions. So the production of the fuels and that the coal that gets burned into thermal power stations and the production of diesel and gasoline that is used in engines. So it's kind of the small percentage of all the energy related emissions of the company. Then there's all of the logistics and transportation associated with moving goods from one side to the other. So the upstream transportation is the emissions of getting things from your suppliers to your company. And then eventually there's down there this category 9, which is downstream, which is getting your products to your clients. There is the treatment of waste, so that's category 5. Whatever waste is generated during operations, it will end up in another company, so it gets disposed of and treated, and that is captured in here. Then there are 2 travel, employee, person travel related categories. There's one which is business related travel. So if you go into business meetings and you catch a flight from Hobart to Melbourne, from Melbourne to Sydney, all of that is captured in there. If you rent a car so you can drive to meetings, the emissions of that driving are captured in the business travel. Employee commuting is the emissions of the use of public transport and vehicles and private vehicles by your employees when they're moving from their home to the workplace and back. And this tool doesn't ask you to know how employees commute, like Maisie explained. We can use average government statistics that capture how Australians commute by region, and as long as the company inputs information on how many employees are commuting per region, the tool can generate those emissions. I mentioned downstream distribution. There's a few categories in here that you see in gray that by working with Timberlink, we understood that probably those wouldn't be applicable to most companies, so we're not asking any information on those. Then there's all the downstream use and processing of the products that are sold by the organization or the company. So if you produce any products that need to be further processed before they can become a finished product, that gets captured in category 10. So for example, if you produce wood chips that get turned into paper, the emissions of the paper manufacturing process fall into category 10. If, on the other hand, you produce products that are ready to use, say, structural timber that only needs a bit of cutting and they go installed in a building, or if you pelletize sawdust, so it goes into boilers, that's going to be captured. The emissions of using those products are going to be captured in category 11. And finally, all those products that are sold by the company, they will have an end of life, they will eventually retire or be consumed, and then the emissions of the end of life treatments, so recycling, landfilling, composting, all of that are captured in category 12. It doesn't work, sorry, I'm figuring out the scrolling. And then a couple of other categories that we assume wouldn't be applicable. So franchises, it's unlikely that you'll have downstream lease assets. If you do have any, you could potentially include that in scope 1 and 2 emissions. Under this guidance, so that's just an informational piece. Under this guidance, there is the data entry part of the tool. So all of those categories are split here into different tables, and each of these rows is are inputs and outputs of your operations and your supply chain that you potentially have. So it doesn't mean that you need to give a number, provide a number for each of these rows, so they might not be relevant, but we try to capture everything that could be relevant for the company. So on the top, we ask about energy. So there's fuels. It's important to distinguish between stationary energy and mobile transport. And if you scroll to the right, there is a little bit of flexibility here because we understand that your records are not, I mean, not every company records data in the exact same way. So here there is the option of choosing the unit. You can use liters, or you can use the generated energy, volume or energy. There is an opportunity to enter data for refrigerant leakage. So some companies, they keep track of all the top-ups that they have to do on their air conditioning. If you're doing a top-up, it's because you lost some refrigerant in the system. So when companies know, oh yeah, we've actually had to put a little bit of 20 kilos of R22 into our system this year, they can put that in here. But we also know that a lot of companies don't keep track because they kind of pay a technician to come in and check their air conditioning, and they don't really know what was the top up. So if you can specify the area of refrigerated space across all of your facilities, if you put those square meters in here, there is an average. We kind of know that a typical facility is going to have a certain rate of refrigerant leakages, so that's going to get captured there. Next is electricity. It's important to define by state, as the national guidance for accounting for emissions from electricity shows that there is a different carbon intensity depending on where you are in the country. We also added New Zealand here because we know that there is a close commercial relationship, and sometimes there are facilities in New Zealand that need to be accounted for. Some companies have adopted renewable energy. They have their own generation, or they purchase mixes from the grid. They pay their provider for some more renewable energy than what is the standard in the grid. So if you specify the percentage of renewable energy that is part of your total energy intake, electricity intake, that gets taken into account here. It's going to adjust the footprint accordingly. It's always important to define the kilowatt hours, so the total consumption in a year per state, and then what's the renewable energy part of that. Then we go into goods and services that are purchased by the company. So we pre-populated this with a list of the likely goods that are purchased. So we have all the types of logs that can be potentially be used. We try to capture as much as possible. They might not adjust exactly with what you use, so feel free to use the best approximation. And then a series of other things like furniture, food if you do catering for your employees, lubricants for machinery, office supplies like books and paper for printers, any products that you might use around the company, like plastics and aluminium products and things like that. So these are fairly generic, and they are so on purpose so that you can find your niche. Maybe if we said aluminium frames or any specific kind of structure, it would be harder to match. So they are fairly high level on purpose. You will notice that we're not asking for how much of each thing, how many items you're purchasing. We're actually how much you spend with them. This is partly because it is one of the data sources for emissions calculations that we could use, but also because it aligns with what a company typically, again, records as data. So it's going to be in your financial records. There are going to be invoices for these purchases, so you can input those here. And the same applies to capital, to services here. So we've got things like the rental of equipment, servicing vehicles, hotel stays, any employee health programs that maybe the company sponsors, marketing things, travel agencies, all the services that could be useful are probably captured here. And the same applies to capital goods. So that this is going to be the big stuff, the machinery, equipment, and things like that. You're able to input data of transportation by vehicle. So if you know very well how your goods get supplied to you, you can specify how many tons are being carried into the company and from where. So if you input that distance, these two figures will give you the emission. If you don't have that information, we did apply some abridged calculations. If you just tell the tool, so we actually get an input of product, and this applies specifically to the logs. We get this many tons in a year, and 25% comes from overseas, 25% for interstate, and 25% for in-state or local, very proximal suppliers. Then it's also going to calculate those emissions. So we wanted to give some flexibility to the user of the tool. Next comes the waste. So there's a few categories of waste that are typically produced by a company. So we have here office-based waste, which is going to be general waste. You know, we got your coffee cups and paper towels and paper that is generated in the office and things like that. And then there's a bit more, there's some waste that gets treated elsewhere from remains of the process, if not everything gets used or sold internally. And then plastics, glass, metals, typical waste streams that you'll see coming out of the company. So your provider should be able to provide you with records of how much of each type of waste they are taking. And here again, there's some flexibility in the units because not everyone measures things the same way. You can either specify kilograms of waste or the volume. A lot of times waste gets captured in, how many bins, in the volume of bins that are taken away. As I mentioned, business travel. So specifying here the spend with air travel, rental cars or taxis or other, which could be, a rail, namely, or ships and ferries and things like that. Then specifying the spend, which there should be also financial records for, will allow you to calculate the emissions for business travel. The transportation downstream, so to clients or to site, works the same way as the upstream. You can either specify the tons of product being transported for each mode of transportation and specify a distance to site or to client, or specify how many tons roughly you're going to sell to each region or radius, so local, in-state, interstate, and overseas. So it's an either or. You either specify the top or the bottom. Then we talk about the product itself. So what happens to the products that you sell? We, again, the tool aims to capture the most typical processed products for the sector. So wood chips turning into paper or MDF, bark that goes to compost, softwood particle board or glulam, and hardwood as well. And then timber in general, we couldn't really specify. In terms of the emissions calculations itself, it didn't really, we couldn't really get a good distinction of what it would look like to have different types of wood into different products. You see here we have pellets, pallets, furniture, cross-laminated timber, plywood, different goods for outdoor or indoor use. So there's a myriad of things that can happen to the timber, and this basically captures the different treatments that the timber needs to undergo. Or if you actually don't know, you can also just use a non-processing, and that's going to be captured as well. If potentially the company sells products that are ready to use, there's also here a few applications, and specifying the amount in tons of product that, or volume that gets sold, then it will also calculate the emission. And finally, eventually, when the products get disposed of, you can specify the quantity of products which should be linked to the above. So whatever flows out of your company eventually will have a end of life. So you want these to match. And you can choose for each of these. You can choose an end of life. Here is landfill or recycling, and specify how much goes to each type of fate, and it's going to calculate the emission.
And I think the key one there for that last point on end-of-life emissions, and particularly throughout, is if you don't have that data, try to make the best possible assumption about it. So specifically with end-of-life, that is a bit removed from your control and your operations. So we do say if you're unsure, the conservative assumption there is that 100% goes to landfill. So do keep that in mind as you go throughout this data entry process. So once you have all of that information input into the tool, you can then click on the carbon footprint results tab. So what this tab does is it takes that detailed breakdown and it provides you with the summarized output. So these top two graphs here, these top two pie charts, what we're seeing on the left is that split between scope 1, scope 2, and scope 3 emissions. So as I said before, this is dummy data, but for any company within this wood products manufacturing industry, we would expect the scope 3 emissions to be the by far majority of your emissions. So as you go through your results and you're trying to understand them, do keep in mind that that is what we would expect to see. And then the pie chart on the right is a breakdown of your scope 3 emissions. So within that, you can try to understand what some of those hotspots would be. And Joe, do you have anything on what the likely hotspots would be within the timber industry?
So this example here, because everything in the data sheet is populated with 100, it's very unlikely profile for a company like wood products. So here we see that employee commuting is as a huge slice of the pie. That's very, very unlikely. Typically, the hotspots are the purchased goods and services, and the use or further processing of products, and also a little bit the logistics. So typically that's where the attention is. A lot of companies, and that's why this is so interesting, because it's very tempting to focus only on measuring what we can directly control. And this tool kind of enables you to actually get a quantification of things that might be escaping the radar. So typically we would first start with measuring the impact of the waste, because it's generated on site. There's things that you can do to start reducing waste to landfill and improve recycling and that kind of thing, and also the employee commuting and the business travel. And it's a natural focus point because it's under control. So whatever emissions occur there, there's a lot of quick wins in trying to reduce those. It's also good to have a perspective of all of the things that are a bit further removed from the company's influence, and those hotspots around logistics and around the embodied carbon of products, and then the use and further processing, they typically pop up in this chart as well.
Yeah, and so I guess the key here is that, as Joana said, the employee commuting, business travel, and waste, really are minimal when you get to that final scope 3 breakdown, because those other ones are so emissions intensity or carbon intense. So do keep that in mind, particularly also in terms of how you're spending your resources and time in terms of collecting data, because really you want to focus on those larger items such as those purchased goods and services, what's happening to your products when they're used or when they're sold or further processed. And if we just scroll down here, you then basically have a breakdown of your footprint by line item. So when we say line item, that is by your scope and category. So this breakdown is as defined in the greenhouse gas protocol, so it aligns to that. And if, for example, you wanted to use this tool to understand your carbon footprint and take the results for reporting purposes, this would align to recommendations of how you might want to provide that information to the public or use internally for your reporting and tracking. So before I jump into the science-based targets results, I guess I just want to say that the purpose of this tool and this project has been to help organizations on their journey towards setting carbon emission targets. And the really important, crucial first step of that is understanding your carbon footprint and measuring that. So if you are a company that's not quite ready to go down that stage of setting targets, you can use this tool to primarily understand your carbon footprint, spend a bit of time collecting that data, understanding your hotspots and the emissions across your operations and what those means and how you can meaningfully reduce against those before you want to jump into the target setting piece. So even if you're not ready for that target setting piece, this tool still can be used in its current form and can really help with that sort of internal understanding and reporting. So if we jump into the SBT results tab, you don't have to input any additional information. You've input all of that information on this questions tab. Basically, we have results of what alignment to a science-based target would be based on the information that you've input. So the key information here is that carbon footprint and also the level of ambition that you've set and your target year and your base year. So those are key to this, these results on this target results page. So I'm just going to scroll down here to demonstrate what the results look like when we look at a recommended carbon reduction target for scope 1, 2, and 3 emissions. So basically what we see in this chart on the right, I'm just going to zoom in actually, is in this scenario, we have a base year of 2018 and a target year of 2030. So what we can see here is business as usual emissions over time. So in this situation, on that question tab, we actually had 0% growth. So that's why we're seeing this business as usual emissions holding constant across the time. And we've set a target pathway. So that's in this sort of lighter brown color. And you can see here in 2030, this target is down near to about 20,000 tons, or sorry, 2,000 tons versus up here at this 5,000 tons. This other axis on the right here is representing your intensity metrics. So as I was saying previously, it's that understanding of your emissions on a per unit basis, so specifically a cubic meter throughput basis. If your company works in another metric, you can basically just enter that number in on the questions tab and just understand that the actual unit that's written down doesn't necessarily apply. The results will be the same, but we've gone with cubic meter throughput here because that's most representative of what we're going to be seeing across the wood product manufacturing industry. And essentially what we see here is that this gap here represents the reduction that needs to be made in 2030. So if I go back across to this side, what we can see here is that the target is a 72.36 reduction compared to 2018 base year emissions. And this translates to a 50% reduction in 2030 compared to business as usual. So if we just go down here, you can see some of these results and you can see what this looks like over time. And we've also provided this breakdown for scope 1 and 2 emissions if you wanted to keep that separate, as well as scope 3 emissions. So you can see the breakdown explicitly for each of those emission levels. If you want to sort of play around with this, you can go back to the questions tab and go up to these different levels of ambition alignment and change them, and the results will change accordingly. So you can, try to understand what some of the differences in alignment might mean, what it means for your company in terms of the quantity that you need to be reducing in the target year. So just to finalize, that is a background of how to use the tool, and this resource will be available free to use on that NIFPI website. So you can use it to understand your carbon footprint. You can also use it to understand the associated science-based targets with your carbon footprint and selected target year. Once you have an understanding of what that target looks like, you can then submit to the Science-Based Targets Initiative if you're looking to have that target validated by the SBT initiative. That basically you would go on to sciencebasedtargets.org and you can download a submission form where you then input the information regarding your carbon footprint and your targets for the level of ambition. You're then committing to set that target and send that into the initiative for validation. They'll then come back to you in 30 business days, and it's the price right now is just under $5,000 for that application. There are other resources that will be available on the NIFPI website that specifically talk you through the Science-Based Targets Initiative process. So if you are interested in going down that road, I highly suggest looking at those resources or popping onto the Science-Based Targets website to specifically understand a bit more about what that commitment is and what it means for your company to make that commitment. So that's really all from us right now, and we're happy to take some questions, unless Joanna, you had anything to add?
A lot of companies are already setting reduction targets, right? You see a lot of companies announce commitments which aren't necessarily aligned to this approach of the SBT. So what's the difference in process and maybe even value?
Yeah, that's a great question. So essentially, what the Science-Based Target Initiative gives you is that understanding that your target is aligned to the climate science. So you can basically have that validation that your company is doing its part, so to speak, in terms of helping to reduce global emissions. By aligning to a process such as what we have presented here, you're also ensuring comparability across industries and across companies and sectors. So, for example, you may not understand whether your target aligns to the level of ambition that, say, Walmart has. However, if you've both validated under science-based targets or followed that methodology, you can then understand either that you are in line with one another, and so it gives you that comparability and a better understanding of what level of ambition means for your company and for your stakeholders and such.
So, for example, if your supplier has a science-based target and they're working with their supplier, no, not their suppliers. If your client has a science-based target and the client is working with suppliers, it kind of gives that reassurance that you share a level of ambition and then gain, right?
Yeah, exactly. And so we did talk about this a bit in the previous webinar and in some of our other project resources, but we are seeing movement to set or to have science-based targets across the supply chain. So for example, property companies are setting science-based targets, and if they are looking for resources to use in their building, and they have science-based targets, they want to know that their suppliers are aligned to that commitment. And so by having a science-based target yourself, you're essentially ensuring that you're kind of positioning yourself to be a top supplier, because you're basically ticking that box for them, that they don't have to worry about your emissions in their supply chain because they know that you also are following that same methodology.
So we got a question there about how companies are encouraged to use this software.
Yeah, so basically we would recommend having a first go at it. So when it's available on the NIFPI website, downloading it, looking at the data requirements, and spending some time to work across your teams to collect that data, input it into the calculator, get that understanding of what your carbon footprint looks like. You can also get an understanding of what that level of ambition would be if you want to go down the road of setting a science-based targets and starting to have those conversations of what it would mean for your company to commit to targets. But basically, if you kind of want to know that you want to estimate the footprint and set a target, what you would want to be doing is potentially going back to this tool on an annual basis to reset that year and basically calculate your emissions and keep tracking it over time. It can definitely be used in that way. We would say that there are some data limitations that we discussed in that in the tool, it's really meant for sort of first users of carbon footprinting. And so there are some instances where it's higher level data where if you've used this, say, in this year and 3 years down the track, you're still using the tool, you might rather want to look at some of these data categories and start thinking about how you can get more detailed data and therefore improve the accuracy of your footprint. So for example, that employee commuting survey, or in the areas where we're talking about purchased goods, rather than using spend, can you actually start estimating those emissions using the quantity of those items and looking at the carbon intensity of those purchases that way? This tool doesn't allow for those updates, but there's certainly resources out there to help you with that. There's consultancies out there to help. We at Edge definitely can, and there are others as well, I'm sure. Yeah, great question. All right, well, if we don't have any other questions, thank you everybody for being on the line today. I hope you've gotten some information and some useful tools that you might be leaning on as they come available online. If you have any questions, do get in touch with us. Happy to answer them and chat more about this in any instance. Otherwise, keep your eyes out on the NIFPI website and you'll find these resources available there. Thanks.